simple and short, okay? Most of Unit 10 is actually stuff that we have done before, okay? It's just in a slightly different context. We're either talking about it in a more general context or it's mostly just we're talking about it in a general context for any specific kind of problem. And some of it's stuff we haven't really talked about since the beginning of the year, so we're kind of refreshing that stuff right there at the end. Because a lot of this is actually what starts at the very, very beginning of Algebra 2, okay? So on Thursday, we went over key features of graphs, and we did all these different examples talking about domain, range, intervals of increasing, decreasing, constant, maxes, mins, axis of symmetries, intercepts, x-axis, all that fun stuff, okay? We did a bunch of those examples, okay? We also refreshed a little bit of transformations. Yeah, that's right. Okay? So we went back over our transformation rules that we've been talking about all year long, okay? So if it is inside the function, it moves it left or right. If it's positive, it moves it to the left. If it's negative, it moves it to the right. If it's outside the function, it moves it up or down. Positive moves up, negative goes down. If we are multiplying by the front of our function, okay? If a is greater than 1, it causes it to
stretch.
If a is between 0 and 1, it causes it to compress. And if we put a negative in the very, very front, it causes our graph to flip upside down. Okay? Now, that is our transformation rules we have been looking at all year long. Okay? Those rules have not changed. Those are what we use to answer all of these questions on Friday. Yep. So that is the rules we use to answer all of those questions. So we are going to look at the back or the next page of this. I think it's page 5.
Yeah.
Okay. And we're going to do very general function explanation of these. Okay. We are not going to put them in a specific function. We're not going to put them in x squared, absolute value, x to the third. We're just going to do them in general function notation where it could be for any function, okay? So when we do that, we're going to write it using f of x. So we're going to be writing functions, and we're going to use f of x as our base. If it goes inside, it goes in the parentheses. If it goes outside, it goes outside of the parentheses, okay? So let's start with number 9. So for number 9, we're looking at translated 6 units to the right. Does that go inside or outside?
That goes
inside. Okay. Inside, what do we need to do? Minus 6, because it's going to the right. Okay. Inside is opposite of what you think it should be. Outside is the same as what you think it should be. Now, we're going to look at number 10. Okay. So number 10 has 2 transformations. It is getting reflected across the x-axis, and it is getting translated 2 units up. So with our function, what needs to happen to make it reflect?
Minus.
Negative in the front.
Oh, that's where it goes?
Yep.
I'll put it in front of that.
To make it go 2 units up, does that go inside or outside of our function?
Outside.
Outside. And we add or subtract?
Add.
So we're going to do plus 2 outside. All right, for number 11, we're looking to it'll be vertically stretched by a factor of 5, and it's going to go left 1 unit. So it's got to go 5. It'll be 5 on the outside. So it'll be 5 f of x. Does the left 1 unit need to go inside or outside? How do I put that? Plus 1. Okay, for number 12, okay, we have to translate 3 units right and 4 units down. Okay, so we're going to have 2 transformations happening. What needs to go inside?
Minus 3.
What needs to go outside?
Minus 4.
All right, then we also have two transformations happening on for number 13. It is getting vertically compressed by a factor of 2/3, and it is also getting reflected across the x-axis. So I know I'm going to have f of x in there, but what else is happening?
-2.
It will be -2/3. The negative causes it to reflect, and the 2/3 causes it to compress. And then the function is just whatever the function is. We're doing it in this general form because if we know how to do it in the general form, we can literally put it with any possible function ever and do it that way. All right, for number 14, it is going to be vertically stretched by a factor of 2. Then it is going to go right 4 and down 2. So we have our function. What all is happening? Yep. And then on the outside, there we go. Okay, that is our transformations. If we can keep our transformation rules down, that section of the test will be super easy peasy. All right. Now, so this next section is function operations. Okay. We actually did all of this stuff during our polynomials unit. Do y'all remember how we were adding and subtracting polynomials and multiplying them and doing all that? It was the test we had before Mardi Gras break. Okay? We did all of this. Okay? The difference was it gave us the problems already set up and told you to add them or subtract them, right? This is giving it to us as it's saying, hey, you have these separate functions, add them. You have these separate functions, subtract them, multiply them, divide them. It's basically causing you to have to set up and solve the problem instead of giving it to you already set up. But we've already done the actual operations. We know how to do the operations. It's just setting them up that we have to add in now. So when we are doing function addition, you will see it written as f plus g of x, which is the same as saying f of x plus g of x. We're just going to take the two functions and add them together. If we have f minus g of x, that just means we're going to say f of x minus g of x. If we have f times g of x, we're just going to say f of x times g of x. If we have f divided by g of x, okay, that can also be written as f divided by g of x, which in that case, we're just going to do f of x divided by g of x. All we are doing is we are just following through on the operations with whatever functions it gives us, okay? So a lot of the way these will be set up is it will give you a set of functions, okay? And from that set of functions, you have to do all of the operations that it asks you to do, okay? So here, it says perform the given operations given the following functions. So we're going to use these functions for all of the questions below it, okay? So we're going to go ahead and we're going to start with number 1. So for number 1, we have f of x plus g of x. That's what we're doing here. So what is f of x? What's the function f of x?
X minus 3.
X minus 3, right? Then we're going to have plus, what's the function g of x? Plus 3x minus 7. We are just pulling whatever our function is from the directions, okay? Now, we're adding them together. So if we look at this, nothing changes with x minus 3. But over here, we have to make sure none of our signs change. A positive and a positive is a positive. A positive and a positive is a positive and a negative is a negative. Okay? So none of our signs change when we add. We just write down the problem as it is. And then we combine like terms and write it in standard form. Standard form means biggest exponent goes first. So in this problem, what would that be? x squared. Okay, and does x squared have any friends?
No.
Nope, so we're just going to move it first. Now, we go to our x terms. Does x have any like terms?
Yeah.
What is x plus 3x? All right, now we go to our constants. Does negative 3 have any like terms? What is negative 3 minus 7?
-10.
So that right there is our answer to this question. So we are just following through whatever operation it asks for us to do with these functions. All right, for number 2. What operation are we doing here?
F minus H.
Yep, so we're doing f of x minus h of x. What is the f of x function? Then we have minus. What is h of x?
Negative 5x plus 2.
Okay, so we have x minus 3. Okay, then we have a negative and a negative, which makes a,
Positive.
and we have a negative and a positive, which makes a
Negative.
negative. And then we write our answer in standard form. So which term needs to go first?
The X.
The x. Does x have any like terms?
Yes.
What?
5X.
What is x plus 5x?
6X.
Then our constant, does negative 3 have any like terms?
Yes.
What is negative 3 minus 2?
-5.
So that right there is our answer. So we are taking the same thing we've already done and just formalizing it a little bit more and being able to do it in when it tells us to and not just when it's already set up for us. Okay, number 3. We are going to do h of x minus g of x. So what is h of x?
Negative 5x plus 2.
And then we have minus. What is g of x?
X squared plus 2x plus 7.
So from here, we have to make sure we have this set up. So we have negative 5x squared, or 5x plus 2. A negative and a positive make a?
Negative.
So we get negative x squared. A negative and a positive make that 3x. Then a negative and a negative make that
Positive.
positive. Now we just combine any like terms. What needs to go first?
X squared.
So I should write negative x squared first. Then what? Minus 8x because we combine negative 5x and negative 3x.
Plus 9.
Plus 9. Because 2 and 7 make 9. And so that right there is our answer. All right, I want y'all to try to do number 4 for me. Okay, set up number 4.
Flip you, man. He said, you got
Constructive criticism.
I don't even know what that is. This is why I'm struggling in it. Because of people like you, I have to use big words. So I have to take a higher English class so I can understand you.
Y'all's math.
I'm good.
Good. No, that's not right. That's it.
That's not right. Is that what your answer?
Okay. We should set this up. So we're doing g of x minus f of x. So we have x squared plus 3x plus 7 minus x minus 3. So we distribute that, and then we end up with
That's
this.
the answer?
It's not plus 7.
Is it plus 3 or
I don't know.
How do you get
X
plus 7?
squared plus.
Oh, I messed up, didn't I? Y'all, I am messing up left and right today. I am so sleepy. So rude.
Just get it.
All right, I think that fixed it. Now, we should get x squared. What? What next?
Plus 2x minus 4.
Minus 4. That is correct. Oh, lordy. All right, now, we're going to look at number 5. So number 5 is asking us to do multiplication. Okay? So we are going to set it up with f of x times h of x. So what is function f of x? What is function h of x?
Negative 5x plus 2.
Okay, to multiply, we have to do what?
Multiply each.
Exactly. So we're going to go through all of this. So we're going to do x times negative 5x, which gives us.
Negative 5x squared.
Then we're going to do x times 2, which is going to give us.
2x plus 2x.
Then we got to switch to.
Negative 3.
Yep, so negative 3 times negative 5x gives us.
Negative 15.
Or positive 15x. And then we have negative 3 times positive 2, which gives us. And then we combine our like terms. So to combine our like terms from here, okay, does negative 5x squared have any friends?
No.
So we bring it down. Does 2x have any friends?
Yes.
What?
12. Wait, 15x.
So 2x plus 15x is?
17x.
Does negative 6 have any friends?
No.
So we're going to bring it down. And that right there is our answer to number 5. Okay? Number 6 is very, very, very similar to that. Okay, so we're going to do the same thing. We're going to do f of x times g of x. What is f of x? What is g of x? X squared plus 3x minus 7. The only thing that's different is one of these has 3 terms. So I have to distribute each one how many times? 3. So we're going to do x times x squared to get
Square.
x cubed. X times 3x to get 3x squared. X times negative 7 to get.
Negative 7x.
Then we do the same thing, but we start with negative 3. So negative 3 times x squared is negative 3 times 3x.
9x. Or negative 9.
Negative 3 times negative 7. Positive 21. Then does x cubed have any like terms?
No.
So bring it down. Does x to the third have any like terms? Or x squared have any like terms?
Yeah.
What?
That's-
What happens with those two?
they cancel.
They cancel. Then we have negative 7x and negative 9x, which gives us
Negative 16x.
plus 21. And that right there is our answer.
What was the answer now?
Negative 5x squared plus 17x minus 6. All right. The division ones of these are actually my favorite. Okay. By far, they are my favorite. So, number 7. We have f divided by h of x. So that means we need to do f of x divided by h of x. What is f of x?
X minus 3.
What is h of x?
Negative 5x plus 2.
Plus 2?
Yeah.
I'm done. That's my answer.
Well.
I mean,
Okay.
Okay, for G, or for number 8, we have G divided by H. Okay, that just means we're doing G of H, or G of X, divided by H of X. What is G?
X squared plus 3x and 7 divided by x plus 2. So you'll never have to actually.
And we're done.
Wait, so we're never, yeah, we're not gonna.
For what we're doing, yeah, we're not going to simplify anything
on the
further than that.
text.
Yeah, we're stopping there. Now, some of these problems, some of them, very few of them, can be factored and canceled, but most of them can't.
Can I simplify?
That's how you would simplify, is you can factor them and cancel.
Yeah.
But I'm not going to make us factor and cancel, so we're good.
Where's our last class?
Yes, ma'am.
I haven't finished my.
Were you not here Friday? Or did
I
you?
was, but I just. I
They didn't
finished
make the
my
paper
review,
cut.
and I'm just.
All right. Now, okay, so the last topic in Unit 10, okay, is the only true new topic this unit, okay? But that does not mean that it's going to be super difficult, okay? So if I gave you this question right here, if I gave you f of x is equal to 3x plus 2, and I ask you to find f of 2, what would you do? Plug in what for x?
The 2.
So you do 3 times 2 plus 2. What is 3 times 2?
6.
Plus 2 would make it.
8.
So when you are doing this right here, all you are doing is changing the input, right? That's all we're doing. So there is something called composite functions, okay? And a composite function just means that you make the input of one function another function. So we're taking a function and we're plugging it into another function. So we're always going to start with the inside function, or the function on the right, okay? And f of g of x does not always equal g of f of x. In fact, most of the time it does not, okay? And so a lot of times with this, you will see it written like this, using these symbols, okay? You'll see how it has that little open circle there?
Yeah.
That just means it's saying g
It's not equal.
of g, or f of g of x. We are just saying f, and we're plugging in g of x. We're saying f of x, but instead of saying x, we're plugging in g. That's all we're doing. Okay, we're just taking the function f and we're plugging in g. Okay, and it is said f of g of x. That's how you say it.
So is it like playing it twice?
Kind of. Okay, so I want us to go ahead and look here. Okay, so we are going to be here doing f of g of x. So we are finding f and we are plugging in g. Okay, so in this problem, we have to plug in which equation? Which is?
X squared.
So I've got to take and I've got to plug that into f. What is f?
2x plus 3.
So we're going to do 2x plus 3. Now, what am I changing x to? X squared. So we just have 2x squared plus 3. When we work these out on our paper, we only have to show this step. We don't have to show anything else. We just have to show the plug-in step, okay? Now, for this next one, we are doing g of f of x, okay? So that means we're going to do g, and then we are going to plug in f, okay? So I'm going to be plugging in f of x. What's the function f of x?
2x plus 3.
Okay, and we're going to be plugging it into the function x squared. So we just do x squared. What am I plugging in?
2x plus 3.
Okay, and And I'm not going to make us distribute the whole thing out. And we're just going to get 2x plus 3 squared. All we are doing is we are just plugging in. Now, you can also have a composite function like this one where it says f of x. So we're going to take our function 2x plus 3 and we're going to plug it into the function 2x plus 3. But instead of x, I need to put
2x plus
2x plus 3. And then to write it, we would just write it as simple as we can. What is 2 times 2x? 2 times 3. Then we have plus 3. So we get 4x plus 9. So all we are doing is we're taking a function and just plugging in a different one. Yes? So now, we are going to look down here, okay? And we are going to use these functions to do all of the problems in this section, okay? So for this first one, we have f of g of x. So I'm going to start with f. What is f?
3x plus 2.
So we have 3x plus 2. Now what is my, instead of x, what do I put here now? What is my g? What am I putting in place of x? Negative x plus 5. You put all of the g function in there for x. Yep. So now, we just simplify that. What is 3 times negative x? What is 3 times 5?
15.
Then we have plus 2. Can I combine any terms?
Yeah.
So we get what?
Negative 3 plus 17.
That is our answer. Okay. For number 10, we are going to do g of h of x. So we are going to start with function g, which is what? What is function g? And we're going to do negative x plus 5. What am I plugging in? 4x plus 3. And then I just simplify. Okay, so from there, the negative and 4x make a negative and a 3 make plus 5. So what do we get as our answer? Plus 2. So on the back, I forgot to include the equations on this section. So what I want y'all to do is I want y'all to take a second and copy the equations from the front to here. I will add them in at the top. But take a second and copy those equations over. Copy in F, G, H, and J. Yes. We're just copying in F, G, H, and J.
Well, you're copying it down. So I'll just. What if I stop?
Oh, what?
Yeah? Okay, we can go ahead and set up G of J of X by ourselves for me real quick. Yes? Can I do what? Yeah, give me just a second. So we're going to do G of J of X. That's what I want y'all to work on now. So when we get this set up, this is what you should have. Okay, then you just distribute. So we get negative x squared plus 1 plus 5, which is going to be negative x squared plus 6. Okay, now we're going to do number 12. Okay, for 12, okay, we are doing f of h of x. So we're going to start with f. What is f? 3x plus 2. And then we're going to plug in h. What is h? 4x plus 3. And that's what we're doing. So 3 times 4x is 3 times 3 is, and then plus 2. So we get 12x plus, what's 9 plus 2? There we go. All right. I want y'all to do number 13 by yourself. You're going to set up h of f of x. So start with h, and then plug in f. It's actually warmer than normal in here today. What flavor is that?
Watermelon. I think Angel from above.
What's wrong with water? That doesn't make any sense. It does. That would be- No, this is why you're on the bill.
Yes.
Would 4x squared be like 16x squared?
We're going to do that one together. All right. So you should get the same answer you got for number 12, 12x plus 13. Those two problems are they're a very special case where h of f and f of h equal the same thing. That does not always happen when you flip the two. Most of the time it does not happen. That's just a special case where it does. Now I want y'all to go ahead and look at number 14. Okay, we're going to do 14 all together. So for 14, it is j of f of x. Okay, so we're going to start with function j. What is function j? So we have x squared. Then what was it? Minus 1. And we are going to plug in f of x. What is f of x? 3x plus what?
2.
So when we square something, what are we doing with it?
Put it twice.
Yep. So that right there is actually us doing 3x plus 2 times 3x plus 2 minus 1. And then we distribute that. So we do 3x times 3x and get
9x squared.
9x squared. We do 3x times 2 and get,
6x.
we do 2 times 3x and get
6x.
2 times 2 is,
Plus 4.
and then we just minus 1. So our first term should be,
9x squared.
then it should be,
Plus 12x.
then,
Plus 3.
there we go. That is our answer to that one. Okay. Now, after that, we are going to look at evaluating composite functions, which that just means we are going to be plugging in a number to a composite function. We can go about these in two different ways, okay? There are two methods we can use to do these, and I'm going to show you both, okay? Each of them have their merits. Just depends on which one you want to look at, okay? So for number 15, okay, for f of g of 2, the first thing you can do here is just find f of g of x. Just do the thing we've been doing. So we're going to start with function f, which is x minus 2. And we're going to plug in negative 3x plus 5.
F is 3x.
Nope, it is a different equation now. Okay?
Oh, I-
Each section will have its own set of equations. Now, okay, so we get that f of g of x is equal to negative 3x plus 5 minus 2, which is what?
X plus 3.
Now, we're going to do f of g of 2. So we're going to take the equation we just found and we're going to plug in 2. What is negative 3 times 2? Negative 6. What is negative 6 plus 3? So that is our answer. When you evaluate, you will have a number answer. Okay, when you evaluate, you will have a number answer. Okay, so that is the first method you can use to do these. Okay. The second method, okay, is you can evaluate it in pieces. So you can take the inside piece and do f of negative 1 first. So when you do that, you will take and do negative 1 minus 2. What is negative 1 minus 2? Negative 3. Okay. Then you will plug in h of what you just found. So you'll do h of negative 3. And so we'll take 2x minus 3, but we plug in negative 3. What is 2 times negative 3? Then we have negative 6 minus 3, which is? And that is our answer. Both methods will give you the exact same answer, okay? They both work. This one just has you set up the problem, then plug in. Whereas this method has you set up each individual piece and plug in as you go. Either way works, okay? The first method allows you to do the exact same thing you've done on all the others first, so that you keep it consistent through all of them and then just plug in. Whereas the second way involves you doing a little bit different. Which way do y'all want to do?
First.
Okay, so for number 17, we're going to do h of g of x. And we're going to plug in. So what is function h for this? Then what is function g? Negative 2x plus 5. Negative 3x plus 5. Okay, then we just distribute. So we get 2 times negative 3x is 6x. 2 times 5 is minus 3. So we get negative 6x plus what? What is 10 minus 3? And then we just plug in what number? What number do I need to plug in? 5. So we do negative 6 times 5 plus 7. Because that is what is right here. Okay, now, negative 6 times 5 is negative 30. Negative 30 plus 7 is going to be negative 23. And that's your answer. All right. Number 18. Okay, did anybody like the second method and want me to go over another one that way? All right. So the rest of you do the method you prefer. I'm going to go over it using the second method. Okay. You take the inside part. So we're going to use this part and we're going to find f of negative 3. Okay, and that is what we are plugging in. So I'm going to take my f function, which is x minus 2. So I'm going to have x minus 2. And I'm going to plug in negative 3. So I get negative 5. Okay. Then I'm going to take and I'm going to do the whole thing again. So now I'm going to do g of negative 5. So I'm going to plug in to g with what I found from f. So g is negative 3x plus 5. So we have negative 3x plus 5. And we plug in negative 5. And so we get 15 plus 5, which is 20. But both methods work just the same. They're both good. They both work. Okay. Let's go ahead and try to get through 19 as well. Okay, h of negative 2. So we can do h of negative 2. Okay, for this, okay, what is h?
2x minus 3.
So we'll do 2x minus 3. And what do I need to plug in? 2x minus 3. Okay, so we do that. We get 4x minus 6 minus 3, which is 4x minus 9. And then we got to plug in what? So we're going to do 4 times negative 2 minus 8. So we get, or minus 9. So we get negative 8 minus 9, which is negative 17. Okay, and that is how we do composite functions. We are now completely done with Unit 10. Okay, that is our last unit of Algebra 1. Okay, so the rest of this week, we are going to dedicate to practicing, and then Friday is our test. We're going to practice and review Tuesday, Wednesday, Thursday. Okay.
Yup.